Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 1210, Introduction to the Sky and Solar System, Lecture 37, Pluto. Now that we've examined the major planets in the solar system, let's start talking about the minor planets in the solar system, and in particular, in this lecture, we will focus on Pluto. We will not only talk about the discovery of Pluto, what was learned during the New Horizons mission that went past Pluto in 2015, but we will also talk about this question, which is, what is a planet? Because of course, Pluto was at the center of controversy in 2006 when astronomers redefined what constitutes a planet, and at that time, Pluto was demoted from being a planet to a dwarf planet. Now, before we go any further in this lecture, I'd really like to hear your opinion. I'd like to know what you think. Should Pluto be a planet? Now, there's no right or wrong answer to this question. I want you to go out to Learning Catalytics, and this is an opinion question. In your opinion, should Pluto be a planet? Yes or no? So go out to Learning Catalytics and answer that right now. All right, I'll be interested to see what the results on that are. Now, one of the debates about whether Pluto should be a planet or not said that if Pluto is a planet, then other bodies in the solar system should probably also be planets as well. So I'd like you to answer this question for me. Should the asteroid Ceres be a planet? Ceres is the largest asteroid in the asteroid belt. It's a little bit less than 600 miles in diameter, which makes it roughly about a quarter the size of our moon, which of course is about a quarter the size of the Earth. So should the asteroid Ceres be a planet? Yes or no? Okay, welcome back. Now that we've gotten those opinion questions out of the way, let's talk about the discovery of Pluto. And of course, it begins with the fact that since ancient times, people knew of Mercury, Venus, Mars, Jupiter, and Saturn. Because those 5 planets, as we would call them today, those 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, are visible with the naked eye. In ancient times, people could see them moving through the sky. And you'll remember from earlier in the semester that the Greeks also believed that the moon and the sun were planets, giving us 7 planets in the sky and eventually 7 days in our week. But with the redefinition of, or with the new understanding of the solar system that came about with Copernicus's heliocentric model, it was realized that the Earth is simply a planet. The moon is a satellite of the Earth, and the sun is the center of the solar system. So in that time, a planet was redefined as one of the bodies orbiting the sun. And at that time, there were Mercury, Venus, Earth, Mars, Jupiter, and Saturn. You'll recall from our last lecture that the planet Uranus had to be discovered. Uranus is too faint to see with the naked eye, and of course on March 13th, 1781, William and Caroline Herschel were looking for double stars. He had parked the telescope in the sky and was letting the sky drift past, and he would read off to his sister what he was seeing in the eyepiece, especially double stars that they were interested in, and an object drifted through the field of view, and it did not look like a star because stars look like little tiny points of light, and this clearly showed a disk. And comets can have a disk-like appearance, and so William Herschel thought that he had discovered a comet. Instead, of course, he discovered the planet Uranus. The next major discovery in the solar system happened on New Year's Day, January the 1st, 1801, when Giuseppe Piazzi, an Italian astronomer, discovered the first asteroid. Now, he named this asteroid Ceres Fernandea in honor of Ceres, the goddess of agriculture, the goddess of grain, who happened to be the patron of the city in which he lived, and King Ferdinand IV of Naples and Sicily. So he combined the two to give it its name, and we still call this asteroid Ceres today. Now, scientists had suspected that there may be a planet between Mars and Jupiter. There is an arithmetic relationship that had been discovered about the spacing of the planets. Today, we understand that this arithmetic formula doesn't have any basis in science, but it is a convenient way to remember the distances of the planets. But there seemed to be a missing spot between Mars and Jupiter. That is, this formula predicted a planet between Mars and Jupiter, and no planet was there. So with the discovery on January 1st, 1801, of this body orbiting between Mars and Jupiter, the solar system gained another planet. At this time, the planets in the solar system consisted of Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, and Uranus. That's right, Ceres was called a planet. But within the next few years, multiple asteroids had been discovered, and all of them were orbiting between Mars and Jupiter. And after a few asteroids were discovered, it was no longer clear that Ceres should be a planet. Just because it was the biggest and the brightest of the asteroids didn't necessarily mean that it earned the status of planet. And we'll see later on in this lecture what became of all of that. But of course, next up, as if you're curious as to how big Ceres is, this is the planet Mars right here, which you'll remember is half the size of the Earth, and that is Ceres right there. So Ceres is about 600 miles in diameter. And so that is Ceres, that is the asteroid Vesta, and these are 3 smaller asteroids that have all been visited by various spacecraft and photographed up close. But that's what Ceres looks like at a little less than 600 miles, about almost 1,000 kilometers in diameter out there in the asteroid belt. Well, of course, the next major discovery in the solar system was the discovery of Neptune on September the 23rd, 1846 by Gale at the New Berlin Observatory. Its position had been predicted by John Couch Adams and Urbain Le Verrier. Well, astronomers watched Neptune over the next few years, or in fact, I should say over the next few decades. And some astronomers felt that, like Uranus before it, Neptune was not properly obeying Newton's laws of motion and Kepler's laws of planetary motion. That is, Neptune was behaving oddly. And one of the possibilities was that there could be a 10th planet out there in the solar system beyond the orbit of Neptune. And astronomer Percival Lowell began the search for that. You'll remember we saw Percival Lowell earlier this semester when we were talking about the planet Mars. Lowell was interested in Mars, and in particular he was interested in the canale on the surface of Mars that had been also discovered by an Italian astronomer. And Lowell built himself a giant refracting telescope at Flagstaff, Arizona, at an observatory now called Lowell Observatory. And he built this observatory specifically with the intention to study Mars and study the canale around Mars. Later, he became interested in this idea that there was another planet out there in the solar system. And so Lowell and Lowell Observatory began the search for the next planet. Now, Lowell passed away before the search ever began. But when astronomers finally got around to conducting the search for the planet, they needed somebody that could do the observing and they could do the very tedious work of very carefully examining the photographs to look for the presence of a new planet out there. The astronomers themselves were too busy with other projects, so they decided to hire a young man by the name of Clyde Tombaugh. Clyde Tombaugh was raised in Kansas. He was an avid amateur astronomer and had built his own telescope. And he wrote to Lowell Observatory asking if they had a job for someone like him. And it just happens that at the time, they were looking for someone to run the 13-inch telescope that had been designed specifically for surveying the sky and looking for a new planet out there. So they hired young Clyde Tombaugh, who took the train out to Flagstaff, Arizona, and he became a staff member at Lowell Observatory. And he had a very tedious job. His job all night long on a clear night was to load photographic plates into the back of this telescope and take images of the sky. He would take an image of a part of the sky, and then he would take an image of another part of the sky and an image of another part of the sky, and over and over and over again. Eventually, a few days later, he would come back and he would rephotograph those parts of the sky. That is, he would rephotograph the sky after a couple days had gone by. And the reason for this is that the stars do not shift in position in the course of a few days, but planets do, because planets are orbiting the sun. Now, if you see a photograph of the sky and there's an object there and it's not there a couple days later, but there's one moved over a little bit, you can't really be sure whether it's that object that has moved over or maybe it's something else. So in order to confirm this, he would always have to go back and take a third plate. That is, he would photograph a part of the sky, a few days later photograph it again, and a few days after that photograph it again. Now he needed to look through these photographs to look for planets. And he did that using a machine called a blink comparator. What a blink comparator do would take the plate from one night and take the plate from another night, and it had a mirror in here that would rapidly switch back and forth between the two plates. And you would very carefully line up the two plates so that they exactly lined up with one another. As you blinked from one plate to the other, the planets which aren't moving, the stars which aren't moving would appear to be in the same place in both plates, but a planet which does orbit the sun would appear to jump back and forth from side to side in the photograph. These are the discovery plates of Pluto, and you'll notice here that there are these two stars right here, and there's this faint one in between, and then a few days later, instead of being right here, the object has moved over there. So on February the 18th, 1930, Clyde Tombaugh discovered Pluto. It was taken from plates. It was discovered on plates that were taken on January 23rd and January 29th. Now, to confirm the discovery of Pluto, they needed to take additional plates, but they suffered through a couple days of cloudy skies, but eventually the skies cleared and they were able to take additional plates to confirm the discovery of Pluto. The naming of Pluto is interesting. It was the name Pluto was actually proposed by a schoolgirl, and the staff at Lowell Observatory liked it because of the PL in the name. You'll remember that the founder of Lowell Observatory was Percival Lowell, and they felt that it was appropriate that the planet Pluto, that's new planet, should have PL as its first two letters in honor of Percival Lowell. So that is the discovery of Pluto. So what we know about Pluto today is it's 39.5 astronomical units from the sun. It takes it almost 250 years to orbit the sun one time. Its orbit is tremendously inclined with respect to the other planets in our solar system. Its orbital inclination is 17 degrees. You'll remember that the next highest orbital inclination was Mercury, which, if I recall correctly, was around 7 degrees. Most of the other planets have all their orbits aligned to within a few degrees. So Pluto's orbit is tilted tremendously with respect to the rest of the planets. It's also on a very eccentric orbit. Its orbital eccentricity is 0.248, which makes it a very eccentric orbit. In fact, it's so eccentric that from 1979 until 1999, Pluto was actually closer to the sun than Neptune was. Now, you might wonder, will Pluto and Neptune ever collide with one another if Pluto crosses Neptune's orbit? Well, don't forget that Pluto's orbit is inclined and tilted tremendously. In addition, Pluto and Neptune have such an orbit that whenever Pluto is closest to the sun, it is well out of the plane of the other planets and far away from Neptune. So it turns out that the two of them will never collide with one another. They never get that close, actually. The diameter of Pluto is 2,200 kilometers, which is about 17% the diameter of the Earth. Its mass is only 0.25% the mass of the Earth, which is very, very small. Its density is about 2 grams per cubic centimeter, and that puts it in an interesting category. It's not as dense as the terrestrial planets, which you'll remember are about 5 grams per cubic centimeter, but it's not as rarefied as the gas giant planets, which are all around 1 to 1.5 grams per cubic centimeter. And then finally, its rotation period is 6.4 days, and Pluto rotates backwards. Well, these are some of the best images that have ever been taken of Pluto up until the New Horizons mission or the Hubble Space Telescope. For the most part, through astronomical telescopes, Pluto looked like a little tiny dot. But in 1978, astronomer James Christie at the U.S. Naval Observatory noticed something interesting about images of Pluto. Every now and then, he noticed that there was a little bulge on the side of the photograph of Pluto. And Christie correctly surmised that what he was seeing here was a moon of Pluto. Now, his wife's name, if I remember correctly, was Charlene, so he wanted something with Char, and someone realized that in the story of Pluto, the boatman that takes the dead across the river Styx is named Charon, and so he gave it the name Charon. And so Pluto and its moon Charon. This is a Hubble Space Telescope image of Pluto and Charon, and you can see that even with the Hubble Space Telescope, you can't see any details on either surface. Now, from the Hubble Space Telescope images and from the occasion when Pluto would pass in front of another star, we had a pretty good idea of how large Pluto and Charon were, and there they are. So that's the size of Pluto, that's the size of Charon, that's the size of Ceres, the asteroid in the asteroid belt, and there is the Earth over there. It's important to know that Pluto is smaller than our own moon, because you'll remember Pluto is 17% the diameter of the Earth. The moon is about a quarter the diameter of the Earth. So Pluto is smaller than our own moon. And there are Pluto and Charon compared to the continental United States, just to give you an idea of how big they are. So that's the two of them. For the most part, astronomers didn't know much about the surface of Pluto or Charon. In the 1990s and 2000s, there were a series of eclipses where the moon Charon passed in front of Pluto. And as it passed in front of Pluto, astronomers were able to judge very roughly the brightnesses on the surfaces of the two planets. We couldn't make out any details on the surfaces, but we could make out that there were dark and bright patches. But nevertheless, Pluto had never been explored by spacecraft. For many years, scientists proposed a mission to Pluto, and NASA would often be interested in the mission. They would start funding some development, and then it would get canceled. And they'd start funding development, and it would get canceled. And they'd fund it and get canceled. There were a number of missions to Pluto that were proposed that had received limited funding to begin designing the mission, only to get canceled later on. But finally, in the early 2000s, Alan Stern and a group of scientists got funding for a mission called the New Horizons mission. The New Horizons mission was designed to travel from Earth to Pluto and take close-up images of Pluto. Now, in order to get there, the New Horizons spacecraft had to travel quickly. And in order to get it there quickly, it had to be low mass and it had to be small. Small because it was low mass. So the New Horizons spacecraft is powered by a nuclear reactor, and it's not much bigger than a grand piano. This is a photograph of the New Horizons spacecraft at a clean room in the Jet Propulsion Lab as it's being prepared for launch to Pluto. And you'll notice it's significantly smaller than some of the other spacecraft that I've shown you exploring the outer planets, such as the Galileo mission to Jupiter or the Cassini mission to Saturn. And this was intentionally small because it had to get there quickly. Or another way to put it, it had to travel quickly just because Pluto was so far away. So here's a schematic of what it looked like. There was a giant antenna that it could use to send radio signals back to Earth and receive signals from Earth. There was a long-range imaging camera down here that could give high-resolution images. There was a radioisotopic thermoelectric generator over here, which was the nuclear power plant that powered the spacecraft, and there were a few other scientific instruments as well. New Horizons was launched in January of 2006. It flew by Jupiter in February of 2007 to use the gravity of Jupiter to give it a boost and speed it up. And what's amazing about this is the Pluto flyby was in 2015. Imagine spending a significant part of your career fighting for and then building a spacecraft to go to Pluto and launching it in 2006 and having to wait 9 years before the spacecraft got to Pluto. So New Horizons flew by Pluto in July of 2015, and then it also flew by Arrokoth, which was another Kuiper Belt object, in January of 2019. So there is the New Horizons spacecraft being packaged on top of the Atlas V rocket that was used to launch it. So what you can see behind it there is the nose cone of the rocket. So that is the nose cone of the rocket that's going to launch it. And there's New Horizons sitting on top of the rocket. Below the floor here is actually the rocket that it's being mounted on. There's New Horizons sitting inside the nose cone of the Atlas V rocket that was used to launch it off to Pluto. Pluto is now known to have 5 moons. The 5 moons of Pluto are, of course, Charon, the big moon that we talked about, Nix and Hydra, and then the moons P4 and P5, which has since been given names, but at the time that New Horizons was launched off to Pluto, those moons hadn't even been discovered yet. Those 2 moons were discovered as New Horizons was on its way to Pluto. Now, the thing about the New Horizons mission, oh, and they were called Hydra and Kerberos, by the way. The 2 moons are Hydra and Kerberos. So the New Horizons mission to Pluto was a flyby mission. That is, the spacecraft would be traveling so fast when it got to the Pluto system that it couldn't slow down enough to get into orbit around Pluto. And so it would literally fly through the system, and it would fly through the system in a matter of just a few hours. So imagine waiting 9 years for your spacecraft to get to Pluto, and when it gets to Pluto, you literally have a few hours to snap all the pictures, gather all the data before your spacecraft moves on and keeps on going. That was the New Horizons mission to Pluto. So this is just a little schematic that shows Pluto and its moons, and it shows the New Horizons trajectory as it came into the Pluto system, passed through, and went on through. Now, I'm going to show you much better images of Pluto than this, but I do have to say that these images in May 2015, everyone thought they were stunning in May of 2015. Remember, the flyby was in July of 2015, so this was a couple months before flyby, and we all thought these images were amazing because these were the best ever images taken of Pluto. And it was really exciting to watch in May and June of 2015 that should be June of 2015, as the spacecraft got closer and closer to Pluto and we were seeing more and more details. And then, of course, came the day, in 2015, July of 2015, when the New Horizons spacecraft flew by Pluto. And I tell you, we could not have been more surprised by what we saw. That is the best image of Pluto after the flyby. Let me tell you what we had expected to see before getting to Pluto, and then what we did see. What we expected to see was an ancient, battered planet. What we expected to see was an icy world because we knew from its density and the objects out at the edge of the solar system, we know that they are icy worlds. But we had expected to find a geologically dead planet, a planet that was completely covered, a body I should say, not necessarily a planet, but a body that was completely covered in craters. It had probably been bashed for billions of years with no changes at all. But now, take a look at that image. Are all the regions on that image old? In particular, there's this one region on Pluto right here called Sputnik Planum. And the question is Sputnik Planum young or old? So I want you to go out to Learning Catalytics, and I want you to answer that question. Is Sputnik Planum, and that's the unofficial name for it, but is Sputnik Planum young or old? So take a look at it right here. Is it young or old? So what do you think looking at it? Well, as you can probably tell from looking at it, it has no impact craters on it at all, which means not only is it young, it is exceptionally young. And this was a tremendous surprise. Scientists had not expected Pluto to be geologically active. Remember, Pluto is smaller than our own moon. Our own moon cooled off about 3 billion years ago. You'll remember that the last major outflows of lava on the moon were about 3 billion years ago. Some lavas continued to flow until about 1 billion years ago. But for the most part, our moon had cooled off and shut down 3 billion years ago. Here's a body that's even smaller than our moon. It should have cooled off long ago as well. Now, the colors tell us a little bit about what's going on here. The white nature of this material on Sputnik Planum tells us that what we're really looking at here is ice and not lava. And in particular, it's not water ice, but it is nitrogen ice. The surface of Pluto is so cold that nitrogen can exist as an ice on the surface. And we are looking at a giant glacier sitting on the surface of Pluto that is made of nitrogen, a glacier that is about 600 miles across, making it the largest glacier in the solar system. We do see that some parts of Pluto are heavily cratered. Some parts of the surface are ancient and old. We see discolored regions that have these red colors on them, and those come from organic compounds called tholins. These organic compounds, when they are exposed to the ultraviolet light from the sun, they turn red in color. Pluto has an atmosphere, and New Horizons was able to study that atmosphere. So we were expecting to find a small dead body, and in fact what we found was an amazing dynamic world that in very recent times geologically has had activity on the surface. But it wasn't just Pluto that surprised us. There is Pluto's moon, Charon, and we saw tremendous detail on that. We'll talk about that in a minute. And we even got some images of the other moons of Pluto. There they are to scale. On Pluto itself, we saw tall mountains, but these mountains are not rocky mountains. It is very likely that these mountains are made of water ice. Again, at this distance from the sun, these temperatures are so cold that water ice is as hard as rock. We see evidence of other geologic activity on the surface. We see large patches of ice with these irregularly shaped segments that have troughs in them. We see dark material that is gathered up in the troughs. We see a pitted surface. There are lots of interesting things going on Pluto. We even see dunes that appear to be ice dunes on the planet that may be caused by the wind in the very, very thin Pluto atmosphere, sculpting these dunes on the planet. And then Pluto's moon, Charon, of course, is a very interesting world. The moon has a giant rift that cuts across the center of the planet, likely caused as a liquid water ocean underneath the surface froze. Tholins on the surface, those organic compounds, these were either released from Charon or possibly released from Pluto and gathered on the surface of Charon and turned red as they were exposed to ultraviolet light. And even interesting puzzling things like the mountain in a moat right here, a very large mountain that is sitting deep inside of a moat. And finally, Pluto's very, very thin atmosphere. Pluto right now is just a few decades after its closest pass to the sun, which means Pluto is still warm from that time when it was closest to the sun. And as Pluto warmed up, some of the nitrogen ice and other ices on the surface sublimated, turned into a gas, and gave Pluto that thin atmosphere that we see today. Likely over the coming decades, as Pluto is moving slowly away from the sun in its elliptical orbit around the sun, it will get colder and colder, and that atmosphere will eventually freeze out. Well, once New Horizons flew by Pluto, the question was what to do with the spacecraft next. Now, we know today that Pluto is a part of a belt of objects called the Kuiper Belt of cold, icy bodies. And so in 2014, a year before the encounter with Pluto, the Hubble Space Telescope was used to search for cold, icy bodies out there beyond Pluto. And in particular, we were trying to find a cold, icy body that was in the right part of the solar system so that the New Horizons spacecraft, after going by Pluto, had enough fuel to retarget itself to get to one of those cold, icy bodies. So in June to August of 2014, the Hubble Space Telescope searched a huge part of the sky looking for cold, icy bodies that New Horizons could visit. And altogether, 3 targets were found: potential target 1, potential target 2, and potential target 3. And potential target 1 was chosen as the body that would be investigated by New Horizons. So New Horizons encountered Pluto in July of 2015. On January 1st of 2019, the New Horizons spacecraft flew by potential target 1. There is the Hubble Space Telescope images showing it. So again, today we use computers instead of blink comparators, but you can see the stars are not moving in this photograph, and you can see potential target 1, that little cold, icy body in the Kuiper Belt, as it moves through the sky as it is slowly orbiting the sun. During the time of the encounter, this body had not been given a formal name. It was called Ultima Thule. Back in ancient times, Thule was sort of the place at the very end of the Earth. And so Ultima Thule would be the most distant place at the end of the Earth. Today, the planet, or the cold, icy body at the edge of the solar system, is called Arakoth. And Arakoth comes from a Powhatan word, Native American Powhatan, that means sky or cloud. And this is Arakoth. So some basic facts about it. Its distance from the sun is about 44.5 astronomical units. You'll remember that Pluto's about 39 astronomical units. It takes a little less than 300 years to orbit the sun one time. Its orbit is not that inclined, not nearly as much as Pluto. It's tilted only 2.5 degrees with respect to the Earth's orbit around the sun. And it's in a mostly circular orbit with a low eccentricity of 0.042. Its diameter, however, is very small. It's 22 by 13 by 9 miles. That's 36 by 20 by 10 kilometers. And it rotates once every 16 hours. And what we believe when we're looking at Arrokoth is what's called a contact binary. These are actually two different bodies that formed at different times, probably came into contact. Well, they came close to one another. They started orbiting one another. And eventually, over time, the two of them orbited closer and closer and closer together until they came into contact with one another. And so these two objects form what scientists call a contact binary. Two originally different objects that eventually spiral together to stick together. So this is Arrokoth's surface. It has a fairly complex geology. It appears when we look at the two pieces of the body that we can actually see some of the basic building blocks that this was made of. The surface is ancient. This is a surface that has not changed in the 4.5 billion years since our solar system formed. And so we are looking at one of the primordial objects of our solar system, one of the very first bodies to form when our solar system formed, and a body that hasn't changed since. And that's why finding and searching for and studying these Kuiper Belt objects is so important. They are the building blocks of the outer solar system, and for the most part, they have remained unchanged. So there is a picture of Arrokoth taken by the spacecraft. Of course, when the spacecraft was far away, the image looks blurry because you couldn't see much detail. And then as it got closer and closer, you can see more and more detail on the body right there. So Pluto and Arrokoth are examples of objects in the Kuiper Belt. The Kuiper Belt gets its name from Gerard Kuiper. He was an astronomer at the University of Chicago and Yerkes Observatory that studied our solar system. And he predicted that out there beyond Neptune should have been a belt of cold, icy bodies that were left over from the formation of the solar system. Now, he wasn't the first one to come up with this idea. Another person by the name of Edgeworth came up with it before him. Both of them didn't picture the Kuiper Belt exactly as we see it today, but for various historic reasons, it has been called the Kuiper Belt in Kuiper's honor, sometimes called the Edgeworth Kuiper Belt, to make sure that Edgeworth gets some credit for this. But in any case, the Kuiper Belt is a belt of cold, icy bodies out there beyond the orbit of Neptune. Now, Kuiper thought that he needed this belt because he thought this was the origin of long-period comets, but not exceptionally long-period comets. There are a number of comets in our solar system that have periods that are measured in many decades or a couple centuries. And that means that those comets typically come close to the sun and then go out about 100 astronomical units or so and then come back in. And there were so many of these objects that Kuiper felt there had to be a reservoir of them out there. And he believed that reservoir was in a belt, surrounding our sun that roughly would have lined up with the planet's orbit around the sun. And today we believe the Kuiper Belt stretches from about the orbit of Neptune, which is about 30 astronomical units, out to about 55 astronomical units from the sun. So that would be the reservoir for some of these comets. And then there are really long period comets who have periods that are measured in thousands or tens of thousands of years. Those comets come from even further out in the solar system, and that area where they come from is a giant cloud of comets called the Oort cloud. And the Oort cloud probably consists of billions upon billions of comets. Whereas the Kuiper Belt is aligned roughly with the solar system, the Oort cloud is probably a large cloud of icy bodies surrounding our solar system. And every now and then, the gravity from a passing star will disturb one of these objects, and they will fall to the inner solar system, where they will become one of our very long period comets. Now, the search for objects in the Kuiper Belt began in the 1990s. When telescopes got large enough, astronomers started using them to search for cold, icy bodies out there beyond the orbit of Neptune. Pluto was called a planet because it was the only thing that was out there. It was the only thing from 1930 up until the 1990s that had been discovered beyond the orbit of Neptune. But beginning in the 1990s, astronomers started these searches looking for cold, icy bodies that were slowly moving through the sky. This is another example of a cold, icy body out there. It's a Kuiper Belt object, 1993 SC. And so it was over here in the first image, and then it moved down here in the second image because it is orbiting around the sun. And now we know today of thousands of cold, icy bodies out there beyond the Neptune's orbit in the Kuiper Belt. So just like there's an asteroid belt between Mars and Jupiter, which contains primarily rocky but some icy bodies, out there beyond Neptune, there is a belt of bodies called the Kuiper Belt, and those bodies out there beyond Neptune are primarily icy bodies. Now, one of the larger, more famous icy bodies is a body that when it was first discovered was given the catalog number 2003 UB313. There is the orbit of UB313 right there. I'll talk more about that in a second. Here are some of these cold, icy bodies. So there's Pluto compared to our moon, compared to the Earth. One of those cold, icy bodies out there at the edge of the solar system has been given the name Quorar. So these are the sizes of the objects that we're talking about. Smaller than Pluto, certainly smaller than our own moon. But here are some of the discovery images for 2003 UB313. Again, it's slowly moving through the sky. So here it is right over here. So you can see in these photographs taken sort of one after the other that the stars again are sitting still, but there's 313 in its elliptical orbit, orbiting around the sun. So today, UB313 has been given the name Eris, E-R-I-S, and it turns out that UB313 has a moon, and the moon has been given a name Dysnomia. And in fact, a surprisingly large number of these Kuiper Belt objects have now been seen to have moons orbiting around them. So that indicates that out here in this outer part of the solar system, the collisions between objects were much more gentle. They were moving much more slower than they are in the inner solar system. You'll remember Kepler's third law says that things in the inner solar system are orbiting much faster. Things in the outer solar system are orbiting much slower. And so because they're orbiting slower and the collisions were less violent, you find a lot of these bodies having captured moons to them. So here is a scale model of the Eris Dysnomia system compared to the Earth-Moon system right there. Once Eris had a moon going around it, once Dysnomia was discovered, we could use the orbit of Dysnomia around Eris to both determine the size of Eris, but more importantly, determine the mass of Eris. We could use Kepler's third law, as modified by Newton, to measure precisely the mass of the dwarf planet Eris. And that's because we know the size of Dysnomia's orbit. We know how fast it's orbiting Eris, how long it takes to go around. And once we know the size of its orbit and we know how fast it's moving, we can essentially use the law of gravity and the laws of motion to figure out how strong the gravity Eris is that has to hold Dysnomia in orbit. And surprisingly, Eris turned out to be 27% actually, more massive than Pluto. Eris is the most massive body in the Kuiper Belt that we know of today. It was also believed at the time that Eris was actually slightly larger than Pluto. Now, Eris has since passed in front of a star, and in this occultation, as they're called, where it passed in front of a star, we were able to use the dimming of the light of the star to measure precisely Eris's diameter, and it turns out that Eris is a little bit smaller than Pluto in size, but it is 27% more massive than Pluto, which means that Eris is about 30% denser than Pluto. So it is much denser than Pluto is. But Eris raised an interesting question. When it was first discovered, it was believed to be bigger than Pluto, and it was definitely known to be more massive than Pluto. Well, if Pluto is a planet, shouldn't Eris be a planet? Because here's a body out there in the Kuiper Belt that's bigger than Pluto. And if Pluto's a planet and you have something that's bigger, shouldn't it be a planet? This was a quandary for astronomers, and the reason it was a problem is that we believe that Pluto and Eris were probably the tip of an iceberg. At the time, we believed that the Kuiper Belt probably has dozens, if not more, objects that are the size of Pluto and Eris or bigger. And the problem with all of those bodies is if we called them all planets, then the word planet isn't special anymore. The word planet is originally designed to mean the major bodies in our solar system. Now, what do we do about Pluto? Since it was the only thing out there initially, it was called a planet. Once Eris was discovered, we were faced with the decision as to whether Pluto should be a planet or not. And if it was a planet, then Eris should be a planet. And if Pluto and Eris are a planet, should Ceres be a planet? Ceres' gravity is strong enough that it's pulled it into a round shape. So if Ceres is round, shouldn't it be a planet? And if Pluto and Ceres and Eris are all planets, then are there other cold icy bodies out there? Could there be 2 or 3 dozen planets? So on August 24th, 2006, the International Astronomical Union was having their annual meeting, and they decided to adopt a definition for a planet. Now, as you'll remember, or as you may remember, this was very, very controversial, because what they did in adopting this new definition was they had the effect of demoting Pluto from being a planet to a dwarf planet. So at this meeting, before this meeting, I should say, even before this meeting, a working group of astronomers had been working on a definition for a planet. At the meeting, it was debated. Their definition was considered. It was modified, significantly, I should add, during this meeting. And then astronomers voted on it. The International Astronomical Union is an international scientific union of astronomers, and they represent astronomers worldwide. And they're there to make sure that all of the world's astronomers are represented. So, for example, today when it comes to naming bodies in the solar system, the name has to be approved by the International Astronomical Union. If you discover an object, you get the right to propose a name, but the International Astronomical Union has to approve that name. They also name all the other objects in the sky. We don't name that many today. Most things are just given catalog numbers. But in the rare cases where something is given a formal name, it has to be approved by the International Astronomical Union. So the definition that they came up for a planet is this. A planet is a celestial body that, 1, is in orbit around the sun, 2, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium shape. In other words, that it is nearly round. What that means is that the gravity of the planet is strong enough that it can crush the material that it's made of to bring itself into a round shape. So Pluto is a really good example. It's primarily made of ice. We could not have a tall ice mountain on Pluto. Its gravity is great enough that that mountain, under its own weight, would eventually sag and depress the surface and spread itself out. The third criteria was that it had to have cleared the neighborhood around its orbit. Now, what we mean by cleared its neighborhood is that its gravity had to be sufficient that for the most part, it has cleared all the other objects out of its orbit. If we think about Mercury, Venus, Earth, and Mars, for the most part, they have cleared all the other bodies out of our part of the solar system. Yes, there are small asteroids that sometimes approach close to the Earth, but for the most part, the inner solar system is cleared itself out. For the most part, the outer solar system has cleared itself out. Jupiter, Saturn, Uranus, and Neptune, their gravity is strong enough that they have cleared out most of the bodies in their orbits. But that's not true of Pluto and Eris. Pluto and Eris are in the Kuiper Belt, and the Kuiper Belt consists of probably hundreds of thousands, if not millions, of cold, icy bodies. And so they have not cleared out their neighborhood, and they don't qualify as being a planet. Now, this was by far the most controversial aspect of the definition of a planet, because it's in orbit around the sun and it's round in shape. That could define many bodies in our solar system. For example, Ceres, the asteroid Ceres in the asteroid belt, would be a planet if it was just those two criteria. But Ceres is not a planet because it's in the asteroid belt and it has not cleared its neighborhood of all the bodies around it. In 2006, astronomers also defined something called a dwarf planet. And a dwarf planet is a celestial body that's in orbit around the sun, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic, nearly round shape. In other words, it orbits the sun, it's round in shape. And here's the important part, it has not cleared the neighborhood around its orbit. So Ceres, the asteroid, because it's in the asteroid belt and has not cleared its orbit, but because it is in orbit around the sun and it is round, it is known as a dwarf planet. Pluto is a dwarf planet, and Eris, out there at the edge of the solar system, is a dwarf planet. there are a few others out there, a few other Kuiper Belt objects that have round shapes as well, that have been confirmed to have round shapes, and they too are now known as dwarf planets. Any other object orbiting the sun is referred to as a small solar system body, and there's lots of other names that are used for them, whether it be asteroids or comets or planetesimals. There's all kinds of different names that are used for them. So Pluto is now a dwarf planet by this new definition, and it is the prototype of a new category of objects called trans-Neptunian objects, which are objects out there beyond the orbit of Pluto. So in 2006, Pluto was demoted from being a planet and it became a dwarf planet, as were Ceres and Eris out here at the edge of the solar system. Now, I can say that the controversy hasn't ended there. There are still astronomers who believe that Eris and Pluto and Charon and Ceres should still be planets. One of the most vocal opponents of the change in 2006 was Alan Stern, the scientist who proposed and then was the lead scientist on the mission to build the New Horizons mission to Pluto. He was the principal investigator, which means he was in charge of the mission. He is still leading the charge today to try and get Pluto turned back into a planet. He's arguing that since Pluto is geologically active, since there have been lots of recent changes on the surface, it is not a cold, dead world, and it should be classified as a planet. Well, we'll see what happens here in the coming years, but as of right now, Pluto is a dwarf planet. But out there at the edge of the solar system, we now know of thousands of these cold, icy bodies, and they orbit the sun in the Kuiper Belt. Some of them are Quorar, Orcus, Sedna. Quorar and Sedna are round, and so they would also qualify as being dwarf planets out there at the edge of the solar system. And then in the asteroid belt between Mars and Jupiter, we have Ceres and Vesta and Pallas. These are asteroids in the asteroid belt that may also qualify as dwarf planets. So after listening to all of that, what do you think? Should Pluto be a planet? So go ahead and answer the question again inside Learning Catalytics. This time I'll give you the choice of maybe. Yes, it should be a planet. No, it should not be a planet. And maybe it should be a planet. So go ahead, go out to Learning Catalytics and answer the question again. I'm curious to see if the numbers change. All right, what do you think? What about Ceres? Should Ceres be a planet? Now that you know how Pluto and Ceres got demoted from being planets, or at least Pluto got demoted, Ceres had only been a planet in the early 1800s. Should Ceres be a planet? And finally, what do you think? How many planets are there in our solar system? How many planets, and again, this is an opinion question. I'm not asking for the factual statement. I want to know how many planets you think should be in the solar system. Are you happy with the current system where there are 8 major planets and many dwarf planets? Would you prefer a system where there are 9 planets in the solar system, the 8 large planets and Pluto, but it does not include Ceres, the asteroid, or Eris? Or do you prefer a number closer to 11? That would be the planets, the major planets. It would include Ceres, Pluto, Eris, and some of the other round Kuiper Belt objects. Or would you prefer a system in which there are 53 planets in our solar system? That is, lots and lots of other cold, icy bodies out there, and even bodies in the asteroid belt that might be classified as planets. Really, it just comes down to an opinion as to which planet, how many planets you think there should be in our solar system. All right. The last thing I will leave you with is this thought, which is that demoting Pluto from being a planet is not the first time that this was done. Remember that for most of human history, there were 7 planets: the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn. You'll remember the 7 days of the week. After the work of Copernicus, Kepler, and Galileo, the Sun and the Moon were demoted from being planets, and we ended up with 6: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Earth was promoted, and the Sun and the Moon were demoted from being planets. Now, you might not consider that a demotion, and that's fine. But then in 1781, Uranus was added. So we went from 6 planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn. In 1781, we got Uranus. In 1801, we got Ceres, and then there were 8 planets in the solar system. In 1802, a 9th planet was added to the solar system. That was Pallas. In 1804, Juno was discovered, so we now had 10 planets. In 1807, Vesta was added. And then between the 1840s and 1850s, there were more than 12 bodies in the solar system, including the planet Neptune. Neptune was added in 1846, and more asteroids were discovered. If you read an astronomy textbook from the early 1800s to the mid 1800s, they would talk about more than 8 or 9 planets in our solar system because they would have included many of the asteroids. But eventually it was realized that because all the asteroids were in a belt going around the sun, and that the asteroids were not large bodies, because even through the best telescopes, they looked like a little tiny point of light. That's where their name asteroid, aster means star. They were star-like through a telescope. They just looked like little dots of light. From the 1850s until 1930, all the asteroids were removed from the list of planets, and we once again went back to having 8 planets: Mercury, Venus, Earth, and Mars, Jupiter, Saturn, Uranus, and Neptune. In 1930, Pluto was added, and we went from 8 planets to 9 planets. In 2004, Eris was discovered, and we went to 10 planets. We may have gone even higher, but astronomers acted in 2006 to redefine what a planet is, and we jumped back down to 8. But it's important to realize that the demotion of Pluto was not the first time this happened. Astronomers demoted Ceres and Pallas, Juno and Vesta. These other asteroids that had been discovered and called planets at the time were eventually demoted to being non-planets. It's an example of how science changes as our knowledge of the universe changes. As we learn more and more about our universe, scientists are constantly going back and re-examining definitions and assumptions that were made in the past. And at times, it requires us to change our definitions or make sure that we account for incorrect assumptions that we had made in the past. And I think this is an example of the progress of science and how science changes over time. So regardless, though, of whether you think Pluto should be a planet or not, it is an absolutely fascinating body out there at the edge of the solar system. Right now, there are no plans to go back and visit it, but I sincerely hope that your generation will build another spacecraft that will travel out to Pluto, but this time, instead of flying by and seeing in detail only one face of Pluto, your generation will find out what's on the other side of the planet. There are still things to be discovered in our solar system, and one of those things are the details of what's on the other side of Pluto. Because in that flyby of just a few hours, we got a very good look at only one side of Pluto. So, thank you very much for joining me for this lecture on Pluto. In our next lecture, we will talk about comets. So join me to learn more about comets.